Everyone, we are doing 2023 level 3 differentiation question 3D. Find the coordinates of any stationary points on the graph or of the function this, identifying their nature. You must use calculus and show any derivatives that you need to find when solving this problem. Right. First of all, what are the stationary points? So first would be turning points. So how do you find it? So you differentiate the function. The first derivative a equals 0 shows turning points. Sometimes it can be point of inflection, but not always. So to find the point of inflection, you have to differentiate again. So second derivative equals 0 shows point of inflection. All right. Now, also second derivative has another function. When you plug the number, so turning point in, if that is a positive, that becomes what? Local minimum, isn't it? If that is negative, that becomes local max. And as I said, if that becomes 0, that indicates that's point of inflection. All right? These are stationary points. Now, to solve this question, I would change that function to negative index. So 1 over x is x to the power of negative 1 minus 2 over x cubed is 2x to the power of negative 3, right? That's easier to differentiate. So negative x to the power of negative 2 and plus 6x to the power of negative 4, isn't it? So in other words, I'm going to write this one first. 6x to the power of 4 minus 1 over x squared, right? So to recognize turning points equals 0, right? So x can't be 0 now. To solve this, we have to times by x to the power of 4 on both sides, okay? So that makes 6 minus x squared equals 0 now. So that means x squared is 6, hence x must be what? Plus or minus square root of 6. So there are two x points, x values have turning points. So let's identify what they are, right? So we have to find the second derivative. So we differentiate this again, yeah? So that is minus minus plus, so x to the power, so that is 2x to the power of negative 3. And then that is minus 24x to the power of negative 5. Okay. So in other words, I'm going to write this one first. Negative 24 over x to the power of 5. And then plus 2 over x cubed. Yeah. So can it be 0? No way, because x can't be 0, can't be negative, x can't be 0. So it is not the point of inflection for sure. So let's identify, if I plug plus square root of 6 into this equation, what do you get? Negative 24 over square root of 6 to the power of 5 plus 2 over square root of 6 cubed. I think I found that. That is negative 0.14. What did I tell you earlier? If it is negative, that's local max, right? So remember the question says find the coordinates, right? So earlier we found x values only. So we have to find the y value as well. So when x is the square root of 6, you have to plug in square root of 6 into the original function here. Then that will give you 0.27. Okay, that's the y value. And this is what? Local max. Okay. So you have to show second derivative, okay? Because the question asked to use calculus, right? And then next, when second derivative, when x is negative square root of 6, you get 0.14. That means local minimum, isn't it? So hence, when x is negative square root of 6, y value, it turns out minus 0.27, and this is a local min. That's how you answer it. All right? Okay, I will see you next time. Bye.